This conference will now be recorded.
So, good morning and good evening once again. So, in the last sorry, two sessions, we discussed about what is performance testing, and we have seen the LoadRunner architecture and some sample record and replay. And yesterday, we have discussed about different types of performance testing. So, where we discussed about load test, stress test, and endurance test, a scalability test, volume test, failover test, and not failover test, sorry, failover test we will discuss today. We already discussed about spike test also yesterday. Now, before discussing this failover test, I would like to explain you a few more concepts. Um, so here, uh, I want to discuss about the importance of software architecture. Okay, so if you are working in any performance testing project, why you have to understand the architecture, the software architecture, whatever the application that you are working, the software architecture you have to understand. Why? I'll tell you. So let's say you are for the application which you are working, there is a login page where you need to enter username and password and click submit button. Okay, that's simple. Now when you enter username and password, okay, and click submit, it is actually navigating to home page. Okay, but the time taken to log in, the time taken to navigate to home page is, let's say, 60 seconds. What do you guys think? Is it okay, or is it okay for the user to take
No,
60 seconds?
no. 1 minute, 1 minute.
60
No.
seconds is like a minute, right? 1 minute is too much for the user to
Yes.
wait.
Yeah. Yeah.
Okay. So what is the standard that we discussed as per the industry standard? What is the
Two.
expectation?
Two.
2 seconds.
Seconds.
In
Okay.
different cases, like 3 or 5 seconds, depending on the
Yes.
project. Now, as a performance tester, you came to know that when you enter username and password and click on the submit button, it is taking 60 seconds. So what you have to do then? How do you know where exactly it is going wrong? Why it is taking 60 seconds? So that means you need to know what exactly is happening when you click on this button, correct? So when you click on that button, what is happening in the backend? Okay, on the UI, I don't know what is happening in the backend. So when you click on this button, where is the request going to, and where it is coming from, and what is the data it is getting back? So all that information you need to know. Then only you will be able to identify the root cause, why there is an issue or why the application is very slow. When you click on submit button, you know that it is slow, but why it is slow is also important for you to know. So for that, you need to understand your project or as of the software architecture, how it is. So that's what I mentioned here. So if you see, what if the login process is slow? So reason could be an issue with the application. Okay, the reason why the submit button is responding slow, because it could be an issue with the application. Whatever the issues because of which this login process is slow, we call it as bottleneck. That means I'm just taking an example, but in general, any slowness, any performance issue is called as bottleneck. In our performance testing terminology, it is called bottleneck. Now, to identify the bottleneck, we need to understand the architecture of the software application. Okay, hope everyone is clear. Now, let me go and try to understand some of the terms that we use in the architecture. The first thing is a server. What is a server? Okay, what is a server? A server is nothing but any program, okay, or any software program, ideally which is understanding your request, okay, and which is processing your request and sending the response back. So this is, let's say this is a UI where you clicked some button, let's say submit button or whatever it is. Then the request will go to server. This is a server. Now the server should understand what you are sending and it should process it, and then it should send the response back. So let's say you clicked on submit, that means the request is going to server with username and password. So this server will understand it. It will validate the username and password. And if the username and password is correct, then it will send a response saying that, like it will send a response to navigate to home page. Okay. So any server, this is the server in here. So anything which is able to understand your request and process your request and then send the response back, that is called as server. Now the server is not a software alone. It is a combination of hardware and the software. Any software cannot run on its own. It has to run with the help of software. If I give you a pen drive, okay, with some Excel or with some formulas in it, okay, with some code or with some formulas in it, with some code, will you be able to run that code without inserting that pen drive into to some systems? No, right? It's of no use. So that means you need some hardware also at some point of time. So a combination of both software and hardware which can understand your request, which can process your request and then send the response back is called server. Okay, so that's what I mentioned here, and you also need to remember this, because every day in our performance testing work, in our day-to-day activities, we keep on using this term server. So you might have heard server is slow, server is not responding. Okay, at least some of you, when when you went, or when you're opening a website, your exam results are out. Okay, let's say your college exam results are out and suddenly you wanted to access the see the results. You try to access, and the server will be slow. Let's say the page will be slow, and and people will say server is slow, server is slow. You go to ATM, it is responding very slowly. You inserted the ATM card, it is taking so long, it is taking time to read your card. Then people say server is slow. Or sometimes if you go to any bank, or sometimes they'll say server is down, server is down. If you go to any airport, they might say server is down, you're not able to book the ticket, like that. So that's that important. Okay, every day from performance testing perspective, we use this term frequently. Okay, now, okay, we know what is a server. Then what kind of software architecture we might have it in our projects? The most commonly used architecture is the Enter architecture, and it can consist of these different components for sure. What are these components? So here, when you perform action, like you click a link or you click a button, the request will go to a web server. Web server will simply process it to application server. Application server will further send it to database server, and the response will come back in the similar direction. Now, let's try to understand what is web server, app server, and database server. What is web server? Web server is nothing but a server which will host a website. You might have heard people saying, "Hey, I developed a website. I'm about to host it. I need to host it on some server." Okay, you created your own website. Now you say, "I need to host it somewhere." Okay, then only it will work. So web server is something which will host websites. What is a website then? Can anyone tell in general what is a website? A collection of web pages. So it will contain so many web pages, right? You click a link, it will go to other page. Either you click another link, it will go to another page. That means it's a collection of web pages. So for every web application, okay, this web server is mandatory. Without the web server, the application cannot be hosted or the application cannot be accessed or run. Okay, so what are the frequently used web servers in any project? The frequently used web servers are Tomcat, Apache Tomcat, and IIS, Microsoft IIS. So Tomcat server is a famous one, which is primarily used for most of the Java applications and other applications as well. IIS is from Microsoft. So basically it is primarily used for .NET applications. It doesn't mean that we cannot use these for other types of applications. We can use, but mostly they will be aligned, like .NET projects will be aligned with IIS, and other Java projects will be aligned with Tomcat. It doesn't mean that it will only work for those. Okay, it will work for everything. Um, so that is a good example of a web server. Okay, now when you send a request here, or when you click a link here, what will happen? A request will go to web server. What kind of request will go to web server? A HTTP or HTTPS request is what will go to web server. Everyone understood? Like you hit a link, you open the browser and you see HTTP HTTPS link on the UI on the browser UI, right? So HTTP or HTTPS request will go to web server, and that web server will simply forward that request to app server. Then this app server is nothing but the application server, which is very, very important. This server will hold or handle the entire business logic. Okay, that means whatever the code that is written by the developer for that application will be resided in the application server. Okay, the entire code of the application will be resided in the application server. Okay, so you you guys know very well, right? Developers write a lot of code. Okay, that entire code will be residing in the application server, and if this application server needs any data, if this application server needs any data, okay, then it will further request to database server. Okay, but before going there, uh, what are the examples of application server? Like you have WebSphere, okay, WebLogic, okay, like that. So you have many, but I just mentioned two. So you have WebSphere, ignore the spelling mistake there. uh, so you have the WebSphere, okay, and WebLogic. These two are application servers. These two are the application server examples, and this application server will contain the entire business logic what the developers write. Okay, now if this application server needs some data from the database to validate, then it will send one more request to this database server. What are the examples of database server in general? So database servers like Oracle, SQL Server, like that. Okay, so now you tell me, now what database server will contain? The entire data related to the application. So yesterday we discussed some example related to the college administration, right? So the college administration will have some database to store the entire data related to the college. So uh, so 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 like that, you need to have a server, database server, which will handle a lot of data. Okay, now you tell me, out of these three, uh, when okay, now when we send some hundreds and thousands of requests from here, let's say using LoadRunner tool or whatever it is, we send hundreds and thousands of requests here, and this will automatically forward to this. Now you tell me, out of these three, which could be more critical? Which is more critical according to you? Anyone?
Database server.
hmm Anyone else?
All are critical.
Sorry.
All are.
All.
Application server.
You said,
All.
someone said all. Okay. Someone said application server. Okay. Actually, all are important, but more critical are these two. Okay. Because this this web server is simply forwarding the request. It's not going to do much actually. It will simply forwarding the request, but the actual load will be applied on these machines. Okay, why? Because developer has written so much code here, and the logics, whatever different logics will be executing, right? All those logics will be executed here in this application server. And to execute that logic, if it needs some data, it will contact database server. Understood? So now, considering that application server and database server will have to handle more amount of load. Okay, see, load will be there on all three: web server, app server, database server. But it will this app server and database server will take little bit more time to respond, right? Because they need to process it. They need to process the process the logics, execute the logics, and all that stuff. That's the reason. In case if you have some issues with the application server, okay, we can actually add few more servers like this, and which is very common in every project. So they will add multiple application servers, which we call instances in terminology. In performance testing terminology, we call instances, or you can also call node, 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 or you call instance. People say app server instance. Okay, how many instances are there in for the app server? I say in my project there are 3 app server instances like that. Now here the web server, what it will do here in this example, so it will simply send few to this and few to this. This will receive few and this will receive few. Now, how there is something called load balancer. We'll discuss later. Okay. So there is something called load balancer which will distribute the load. Okay. That is a different aspect. Now, when you add some servers like this, that is called scale out. Okay. When you add additional servers like this, you call it as scale out. Now, in some projects, the project management will think that they don't have budget to add new servers, or they don't want to add new things. They just want to enhance or upgrade the existing software. So in that case, the they will upgrade this machine configuration like RAM, CPU, and all that stuff. So when they upgrade the existing one, so that is called scale up. Okay. Now you can ask me, sir, in that case, will they not upgrade database server? Will they not add any additional database servers? See, basically, for database server, the the organizations, what they do is they buy a database for some capacity. For example, I want to buy Oracle database, okay, for my project. Then I need to tell Oracle that, hey, my business will have to handle, like, let's say, uh, 2 million records. 2 million records data it will handle, okay, approximately. So give me an Oracle package, database package, which will be able to handle or store 2 million data, okay. And if they feel that they are reaching 2 million data, or they feel they need more capacity, they will simply ask Oracle, hey, can you upgrade my database package? I need like 5 million data storage. So they will give you another package. They will charge for it, but they will give you another package with 5 million data capacity or storage capacity. Okay. So like that. And here also, um, like, okay, I'll tell you that point later. But did everyone understood these important points or no?
Yeah.
Okay. So in
Yes.
every project, you might have these components: web server, app server, database server, for sure. Okay, and load balancer also. We'll discuss that load balancer algorithms and all in our upcoming session. But for time being, this could be the components of your architecture. Now, one more important thing is protocol. What do you mean by protocol? In general, if you go by a dictionary definition, okay, protocol means some set of rules. Okay, protocol means some set of rules. Earlier, I told you that there will be a client and there will be a server, and the request will go from client to server. That's what we discussed, right? Now, server, what server will do? Can anyone tell what server will do? It will,
It process the request and get the
it will,
response.
yeah, it will understand the request, it will process the request, and it will send the response back.
Response,
Now,
yes.
the question is, how will it understand what the client is sending? So, client is sending something, but how this server is understanding it?
The
So,
use of
they,
protocol.
f- yeah, so they follow some protocols. Protocol means some set of rules. See, if two people want to communicate with each other, they both need to understand some common language. Okay, otherwise they both cannot communicate directly. Similarly, if client and server wants to interact or communicate, they both need to I mean, at least the server need to understand, and both client also need to understand, because it will get the response back. So both should understand what they are sending, okay, and receiving. So how they understand is they both follow some set of rules, what we call as protocol. See, protocol is nothing but some set of rules. Depending on the kind of communication required between client and server, protocol will be selected by the project architect. As a performance tester, you are not going to decide the project architect. It will be decided by the development team, and in the development team, they will have some SME, the subject matter expert, or the project architect, who will decide what kind of communication is actually required between the client and server, and based on that, the protocol will be decided. Now, if both client and server are communicating, okay, between each other on for a through a for a web application kind of thing over HTTP, then they need to use a HTTP/HTTPS protocol. If the communication between client and server is all about exchanging files or transferring files between one machine to another machine, then we can use file transfer protocol. If the communication between client and server is all about exchanging emails, then they might use SMTP, Simple Mail Transfer Protocol. Like that, you have so many protocols. Depending on what kind of communication you are making, you can choose you can choose the protocol. Okay, and who will select the protocol? The project architect will decide the protocol. How do we know which protocol they have used? That's what we have to gather the information from the application team before sorry, before you start working on any project. You need to gather that information. So what kind of information you need to gather? How do you gather it? Do you have any format or any template for it? Yes, we do have, and that template and all that stuff we will discuss in our next session. Okay, so these are the different important terms that we need to understand before going further in our course. Okay, now because now you know about servers and application servers and all, let's try to understand this failover test. Okay, so it is also one of the type of test. Now let's say I told you there can be multiple instances of server, yes or no? So let's say this is server 1, this is server 2. Let's say here you have a client, or let's say this is LG machine, load generator machine, from where the load is being simulated, or let's say it's a client from where the requests are coming from. Then in between, okay, let's say there is something called load balancer. There is something called load balancer. Okay, let's say this is client or LG. Let's say this is server 1, this is server 2. Now, from here, let's say some 1,000 requests are being sent. When I run the load test, let's say 1,000 requests are being sent. Now, what exactly we are trying to do here as part of failover test? As part of failover test, you will definitely have a multiple server instances like this: server 1, server 2, server 3, server 4, like that. And as part of failover test, what we are exactly trying to do is, if any one of the server is down for some XYZ reason, how the other servers are handling the load is what we are actually verifying in the failover test. Sorry. So how do you simulate this scenario? How do you test this scenario? So load balancer will be there in your architecture. Okay, don't think much about it. But what exactly it will do is, it will distribute the load between different servers. Okay, now let's say 500 are coming from client, so it will send 250 to here and 250 to here, one by one, like this. Okay, it will follow some algorithms on what is the pattern to distribute, that we'll discuss later. Now, how do you test this failover testing concept? So what I suggest is, so inform the developers, okay, or the admin team, that let's say tomorrow morning 9 o'clock you want to run the failover test. Okay, tomorrow morning you want to run the failover test. So inform the development team or the admin team who have access to bring down the servers and bring up the servers as and when required. So let's say 9 a.m. Okay, let's say tomorrow morning 9 a.m. to 10 a.m. you want to run the failover test. 9 a.m. to 10 a.m. I want to run the failover test. What exactly you do here is, uh, before 9 a.m., let's say 5-10 minutes before or 5 minutes before the test, you schedule a call or schedule a meeting with the development team or the admin team who have access to bring down the servers and bring it up and run. Now, once you join the call, okay, at 9 a.m., ask the developer to don't do anything. Okay, 9 a.m. to 9:15 a.m. 9 a.m. to 9:15 a.m. Run the test. Okay, run the test with same volume as load test. Whatever the volume you have, that with the same volume you can run the test. Start the test. 9 a.m. to 9:15 a.m. you are running the test. Okay. Now 9:15 a.m. Okay, you ask developer to bring down, let's say server 2. So this server, okay, let's say this server should be brought down, okay, and it should not be active. So from 9 a.m. to 9:15 a.m., one request is going here, one request is going here, one request is going here, and one request is going here. Okay, so the load is being distributed from 9 a.m. to 9:15 a.m. At 9:15 a.m., you ask the developer to bring down the server 2. So what does that mean? So developer will bring down this machine. That means he will bring down this machine, and then what will happen? What you have to verify in this case? So when okay, I'll write it here. When server 2 is down, how server 1 is able to handle the load? How the server 1 is able to withstand the load? Okay, so from 9:15 you ask the developer to bring down server 2. From 9:15 the server 2 is down. So now when from 9:15 what will happen is, from 9:15 all the requests should go only to server 1. There is no contact or communication between load balancer and this server 2, because when a server is down, this load balancer has the capability to understand that the server is down. Basically it will all happen in like few seconds, like in 3-4 seconds itself, or 5 or 6 seconds itself, the load balancer will come to know that server 2 is down. Now when server 2 is down, what the load balancer will do, it will route all the requests Okay, it will route all the next requests or upcoming requests to server 1 itself. So the server 2 will not have any connect anything because it is down. Okay, then what you have to verify here, from 9:15, let's say till 9:30 you are doing this process. From 9:15 to 9:30, how this server 1 is handling the load. Okay, how this server 1 is handling the load, and is it able to send the response quickly? Is there any impact on the response times? Okay, because it is taking more load, right? So there is every chance that server 1 will have some performance issues, like in terms of response times, and you have to verify the CPU utilization, memory utilization, and all that stuff. So we'll discuss those things later. But what I what I want to tell you is, like, from 9:15 to 9:30, this is the only server which is handling the entire load. Okay, and then you monitor the performance of it. Where you monitor, you can use any APM tool like Dynatrace or AppDynamics, which we'll discuss later. Okay, in our upcoming sessions. So you can use any APM tools like Dynatrace or AppDynamics. Okay, I'll cover Dynatrace and AppDynamics in our upcoming sessions. Okay, so at 9:30, what you do is, okay, this process will continue till 9:30, and you continuously monitoring server 1 using AppDynamics or Dynatrace or any APM tool. At 9:30, what will happen? You ask the developer, okay, you ask the developer, 9:30, you ask the developer to bring server 2 back to normal. That means developer will bring this server back. Okay, developer will bring this server back, and can anyone tell what will happen once the server is back? What will happen? Can anyone tell? Now this server is up and running now. Developer brought it back immediately. When I told around 9:30, developer brought this server back and it is running now. It is up and running. Now what will happen from 9:30?
Balancer will be routing the request to both server 1 and server 2.
Correct, because load balancer have the capability to know that this server is again up and running. Okay, it will have that. It is having that capability. So load balancer will come to know that the server 2 is again up and running. Now after after 9:30, okay, after 9:30, so one request will go here, and the next request will go here, and the next request will go here, and the next request will go here. Will go here, and the next request will go here. So you can continue this for 30 minutes or 15 minutes. Similarly, if you have more time, now you can bring this down, server 1 down. Okay, you can try that also. But because we have only 2 instances, you can make any one of the server down. But in general, if you have 3 instances, for 15 minutes we'll bring one instance down. Another 15 minutes we'll bring 2 instances down. Okay, and we'll run only with one. It's like it's like flight running with 2 engines, and if it has any problem with one engine, the other engine should be able to handle, right, until it reaches the next airport. Yes or no? So that is what we are testing here also. Before even we get some issues with the servers in production, we are thinking that what if some of the server goes down, how our application is able to withstand the load. That's what we are actually testing here. Any questions?
So in this test, we are continuously switching the servers, sir.
Not continuously. I mean continuously in sense, like, we we test it for some few minutes, like 15-20 minutes, and see how it is performing, and then we switch between servers. We'll bring it up and back to running. So we'll write down few scenarios based on the number of instances you have. You make a note of these scenarios and tell and share those scenarios with the developer before the call itself, that you want to run a test like something like this. Now let's say you have 3 server instances. Now first 15 minutes you want all 3 to be up and running. Next 15 minutes you want one server to be down and 2 up and running. And next 15 minutes you want 2 servers down and 1 up and running. In the last 15 minutes you can again bring all 3 up and running, like that, and then see how it is performing and all that stuff, how the other servers are able to handle the load, if any one of the server has issues and all that stuff. So so Basically, in nowadays, in every projects, you will have multiple instances. You will not see any project with only single instance or single server. You will definitely have multiple server instances, because if you have a single server instance, right, and if that is down, that means the application will go down, right, and the users will not be able to use it. So that is not the solution nowadays. At any point of time, the application should be up and running. The downtime should be very less. Okay, the application being down should be very very less. The time take it is it is down should be very very less. Okay. That is called downtime. So this test is something which we have to depend on development team or some other admin team who have access to bring down the servers. Okay, that's the reason I explained today, because to understand this, you actually had to discuss something about servers and server instances and all that stuff. That's the reason we discussed it today. Okay, and actually this was not there in earlier days. I mean, a few years ago, if you ask me failover test, if anyone were doing failover test in their projects, basically no one were doing that at that point of time. In the recent past only, uh, uh, projects are trying to run a stress test something like this. Okay, so that uh, they will have some idea about how the application will run in production if something goes wrong.
Hello,
Yeah, go ahead.
sir. If any one server is down, then other server response times should be the same. If
No,
they
it
are
can.
running with two servers.
Correct. See, it need not be same. It can be little slow, but the only thing is customers users should not feel a lot of big performance issues. Okay, so basically what happens is when any one of the server is down, immediately the teams who are responsible for looking into it, they will actually look into it and bring it up, but they might need some time, like 5 minutes, 10 minutes, 15 minutes, 30 minutes sometimes, or sometimes 40 minutes or 1 hour also, because they need some time to see why it is down and they need to bring it up. They might take some time, like 10 minutes, 15 minutes. Now during that 15 minutes time, how the other servers are responding, they will be okay if it is responding little slow. Okay, 100% sure that the client will be okay if the other servers are responding little bit slow, but it should not be too slow. Okay, it should not be too slow, but definitely there will be slowness. See, there are three server instances. Let's say it's a three server instances. Each server instance is getting 5,000, 5,000, 5,000. Now you are bringing these two down. Now this alone is handling 15,000. Obviously that means it is handling thrice the load, right? Three times the load, like, than a normal time.
Hmm.
So that means obviously it will have pressure. Okay, that means it will respond little slowly. Obviously, response slowness will be there, but how much slowness is there? Uh, is that okay? Is that acceptable for the client? Okay, that's what we need to discuss. So when you run this failover test, how the other server is responding when one of the server is down, how much is the response times, that we have to tell as an observation to client and the application team. They will decide whether that is okay for them or not. If client says my response time, if I'm okay with the response times of 8 seconds, 10 seconds, even if one of the server is down, I'm okay with 10 seconds response time, then no problem. Okay, but if a client says I'm not okay with 10 seconds and all, they will come up with a solution. But our job is to tell them how the servers will behave if the other servers are going down. How these servers will respond or behave is what we are going to identify and inform the client upfront. Okay.
Okay.
Okay, yeah. So that's about the failover testing. And also, um, so how this client is getting this 500 users here? Who is giving these 500 users? From where they are giving these 500 users? Okay, what if the client is not aware of the performance testing itself? How do you handle then? Then all these topics we will discuss tomorrow. Okay. One before we wrap up the session, I'll tell you one more. I'll show you one more slide. So this slide is nothing but the life cycle of the performance testing, or you can say a different phases of performance testing. Performance testing. Now, if you attend any interview, they will ask you a question that what are your day-to-day activities? What exactly do you do in your performance testing project? Then you have to say, uh, in my project, I was involved, or I was doing, or I was participating, or I was involved in all the phases of performance testing lifecycle, right from NFR, that is non-functional requirements gathering, till reporting and recommendations. That means every performance tester has to know or participate in all of these different phases of performance testing lifecycle. Okay, so these are all the high level roles, or sorry, high level duties of a performance tester. So on the left side, whatever you're seeing, all these are document based. On the right side, whatever you're seeing, all these are tool based. So that means you develop scripts, you prepare test data using tool, you develop scripts using tool, you design your scenario and execution using tool, you analyze the results using a tool, you provide your recommendation reporting and recommendations using some tools like Dynatrace and all. Okay, on the left hand side, this is non-functional requirements gathering. So this is a document based. We will discuss this. We'll discuss that in the next session, or the other session. We'll also discuss this test plan, what should be our test plan, how we have to test, what should be our test strategy, and all that stuff. And we'll also discuss this workload modeling, which is again very very important. So these are more of document based or like that. And these are all the tool based concepts. So every performance tester will involve in all of these different phases. Okay, earlier days, like if you ask me 5 years before, or 7 years before, or 8 years before, team members used to team members used to team members used to participate in this and this. Team leads used to mostly focus on this, and team leads used to mostly focus on this and partially support uh, in reporting, recommendations, and analysis. Okay, team members strictly used to handle the scripting, test data, and all that stuff, scenario design, and all this stuff. But nowadays, every team member should participate in all of these different activities. Okay, so tomorrow we will discuss what is this NFR, and yeah, we'll discuss what is this NFR, or and also one more thing. Yeah, we'll discuss this in the next session. Okay, any questions? So I'll give you our 15 minutes back today. Okay, so we'll continue from the next session. So if you have any further questions, right, do let me know. Or if you have any other questions related to the course or anything, we can discuss. We still have some time, right? Yeah.
One more question. When is the real session starting? When is the course starting?
The course already started yesterday, right?
Okay. Well, I thought this was just okay.
No, no. So no, this is definitely not a demo. These are all the important things which are asked in the interview.
Okay.
Okay. Without these interview, without, I mean, whatever we are discussing yesterday, today, and in the next two sessions also, they might be theoretical, but that's though you will definitely get mandatory questions from these in the interviews. Okay, so in the next session when we discuss about non-functional requirements gathering and how we understand the volume and all, that mandatory will get a lot of questions from the interview perspective. Okay, so maybe so what we are going to do is we are going to discuss this and this, so these things quickly in next two sessions. and then we will switch to the tool and start the scripting and all that stuff. Okay. Any questions?
Apart from AppDynamics profiler tools, right? Can we discuss JProfiler because some of the companies using JProfiler, right?
Uh, See, we can discuss, but the thing is like um, those are all outside of LoadRunner. So I mean, I cannot. There are multiple tools available in the market.
Yes,
So
yes.
yeah, I agree, but we cannot cover all the tools in the course, right? So
Yeah,
actually,
but
whatever the J profiler, whatever you are telling, actually those are part of performance engineering course actually.
mm, mm, mm,
Okay.
mm, mm.
So what I'm trying to tell you is the tools which I am covering as part of the course, they are definitely part of our real-time projects. Okay. So if let's say it, I'm just kidding. So I mean, I'm sorry, I'm just saying like out of 100 projects, if 50 projects are using Dynatrace and if 20 projects are using, let's say, JProfiler, or if 10
Mm.
projects are using AppDynamics, if 10 projects are using Datadog, if 10 projects are using New Relic, so we cannot cover all these
Yeah,
tools, right,
yeah.
in one session. So that's what
Uh,
I'm saying. So the concepts are same. The tool might be different. That's the reason I'm covering Dynatrace and AppDynamics for you.
yeah, then we can correlate JProfiler and AppDynamics,
Obviously,
right?
yeah, obviously. But I'll see if time permits, then I'll try to configure JProfiler in my machine and try to, I know, give you some high level info. But I cannot assure you that I'll do
Okay,
it.
no
Yeah,
problem. Can you
yeah.
please
But if time
give us
permits,
some
I'll definitely
example?
add it. Yeah, yeah.
Okay, okay.
Hmm.
Thank you.
Okay, yeah. Any other questions? Okay, so just go through these recorded sessions, demo session and day one and day two, and uh, then we'll discuss some good interview questions in the next two sessions. Um, and then we'll switch to practical sessions again. Okay. So thanks everyone. Let me check if any questions in the chat. I didn't see chat today actually. Sorry for that. Yes. I'm going to give the running notes. Whatever we discuss, all those things you will get it. Yeah. Whatever I write, whatever the notepad we use, whatever the running notes we use, everything you will get it daily. Okay. Okay. So let's meet again in the next session. Yeah. Thank you so much.
Okay.
Thank you.